Hey, what's up, guys? I wanted to go ahead and revisit the reverse engineering examples for defusing the bomb. I think there's a lot of hand waving that had to be done in the name of time. So putting this in a video will be able to show you how to get process under a debugger, start reverse engineering, and get all the details out of the way. So let's start with our examples we did, which are bomb simple and bomb hard. And once again, if we start bomb simple, it tells us there's a bomb on our box. Enter a 8-digit password to defuse. Press enter, and of course we always lose. This is a good candidate for reverse engineering because we have full access to the exe, and we can crack this in a number of ways. We can steal the password out of it. We can bypass the access check it does. It's on it. We can do just about everything. So let's close that and open up IDA here. IDA is an awesome tool. It's not required at all for cracking these simple binaries, but I think it's a good thing to start learning because when you hit more complex applications, you're definitely going to need IDA. So it's this simple. You just click drag the bomb into IDA. Yes, get symbols. Yes, proximity view. And here we see a little map of how the code looks. So we see there's a function called tmain crt startup, which calls main, and main calls all of these functions. I happen to know from writing this code that main is the part where we want to be. It's where my code begins. This is the stuff I wrote. This thing up here, that I think that's compiler generated. So we don't want to go into there. We want to go into here. So click on the main, and then press spacebar. Now we end up in this nice layout of assembly code that was compiled from my application. And you can see strings here like there's a bomb in your box. So we definitely feel like we're in the right place in our code. So that's good. We got IDA on track. Go ahead and fire up OllyDebug, which you want to run OllyDebug as administrator. And OllyDebug is a debugger, which again, a debugger is just something that can analyze an executable running at runtime, and we can pause it, step through slowly, and change things. So they're very powerful. I would go ahead. You want to open, so click the open button. Browse to the exe you want to debug. So bomb simple. And here, right when we loaded it, it broke at module entry point. This is there's not even a welcome banner was generated yet because we are truly at the beginning of our code. Nothing has ran. And you can see the first function here is a call. A call in assembly is just a opcode that calls a function at a certain address. So here it's saying call the function at address 01182E41. There's two things you can do when you hit a call. You can step over or step into. And step into, which is the F7 button in OllyDebug, what it will do is it will actually go inside of the function and trace the code line by line so you can analyze the contents inside the function. Where F8 is a step over, and that will run everything inside the function, but don't make me have to look at it. And there's a time and place to step over and a time and place to step into. So I'll show you what they look like. If I press F7 here, I end up inside of that function. That's what this was, this function. This is what the call was calling, all of this stuff. Let's restart it, and we're at the call again. Press F8. What that just did was it ran everything in this function, but we didn't have to look at it. So make sure to utilize both those when they make sense. And you have to be careful if you step in too much, because reverse engineering is all about rabbit holes. There's function calls within function calls within function calls, and you can be like 12 functions deep, and it can get kind of intense. And one thing to kind of help you out is when you know when you went too far, when you end up in address space that is this is kind of a weird rule, but like typically addresses that, so these are addresses. Typically addresses that start with a 6 or higher. That's you're in Microsoft DLL code, and I'll show you what that looks like. If I hit F7 here, I keep stepping into like everything I see. So I hit another call. So if I hit F7, I'm going to go inside that, and here I am. I'm in this confusing DLL space that I have no business being in. Nothing is going to help me out if I debug this section of code because nothing. This is not my program. This is just DLL helper function. So whenever you get in here, what I do to get out of it is hit execute till return. So it runs everything in that in my function that I mistakenly ended up in until we hit a return, and then all I have to do is hit F7, and we're back in our main application's address space, which is where we want to be. But you can see here, some of this looks a little confusing because I know, for one, I wrote the code and I don't remember writing any of these functions like get file system as time, query performance counter. No, that looks like compiler generated stuff. So we're a little bit lost in the debugger. And this is what IDA can come in handy for. Well, actually, in this case, I'm going to show you how to get on track without using IDA. If you just had a debugger and wanted to know where do I get, on track so I can know where I'm at in the code, you can click strings here, and strings parses all of the strings out of the binary so that we can see them. And we know this one looks very familiar. There's a bomb in your box, enter 8-digit password to defuse. We know that that is near the beginning part of our runtime. Double click that, and we end up right here, and we can see this is the beginning of the function. So it's safe to say all this is really like the main kind of program, and really this is the same as what this is on the right side, just IDA got us there a little quicker. And if we scroll down, let's put a breakpoint. Let's put a breakpoint right at the part where it loads that string and press play. Alright, nothing's showing up here because when the string first has to be loaded, that the instruction here is saying load the string in the register EDX. If I expand this out a little bit, we can see this is register EDX. It just loaded that string address into the register, and then it's calling a function. I happen to know this function is a print function, and if we call this, once we step over that F8, it just printed that out to the console. If we keep stepping over, we're just going to do F8, 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 because I kind of know what to look for here, F8, F8, and we already see something very, very interesting. The password in plain text is being loaded into a register, and what you could assume is that the rest of this is just going to do checks to see if the strings are equal, to see if the password's equal, and if it is, jump to a win condition or jump to a lose condition. Well, since it seems to be that easy, let's just use the password right out of the binary that we stole. So 5986141, and it broke here, but that's okay. Just click continue, and we won. So that one was very easy. We stole the password plain text out of the program. Let's move on to the harder one, which is bomb hard. Load this into Ollie debug, ignore that, and load it into IDA. Alright, once again, click main, press spacebar, we end up in our code. It looks very similar to to bomb simple because we see there's a bomb in your box and all the rest of the layout. So I'm going to show you another way to jump to get your bearings, to jump to the part of code of interest. Since in IDA we already know this is where we kind of want to be, click right here at the very first instruction in this main function, and look down here. You'll see this is the addresses that instruction is at. The address on the right here is the absolute address, and the address on the left here is an offset. I encourage to always use offsets because if we go off the absolute address here, binaries can change where they're loaded in memory, so it won't always be that exact address that this instruction is located at. It's better to go off of offsets because offsets are flexible to the changing nature of where binaries get loaded into memory. So the offset here is saying it's 890 bytes from the beginning of the file or the base, and this is in hex. So what we can do here, let's put these side by side. We can press Control G in Ollie debug, and what this is doing is it jumps to wherever we want in memory. Click the offset button here, and for some reason it defaults to some crappy DLL. I don't know what that's about. but you want to select our actual application we're debugging, and then type in that offset we want to jump to, which is 890. Click OK, and boom, we just jumped right to the part where we want to be. And what you can do here is press play, and we broke right at the beginning of the application, where things get interesting, and it's about to load these strings. So let's just step through. And what you can, oh wow, I already gave some, this is already a, I had to save my progress last time, or OllyDbg did. Let's go ahead and act like that's not there, and look at this, the code in IDA. We know that on bomb hard, the thing we've noticed about bomb hard, here I'll run it actually again. With bomb hard is it wants an 8-digit password, but even if we enter in that one password, whatever it was, let's say if that's it, we always lose. So this is like, this is a little bit different. And when we run when we look at strings in it, we don't see a password in plain text. So this is like a bomb that is a little bit more tricky to defuse. We don't know what condition can actually defuse it. What you can do here when you're stuck here is click View, open Subviews, and look at strings. And we know the lose scenario that we keep going down is you let the Russians win. No matter what password you enter in the bomb hard one, we end up here. So double click this, and this takes you to the part in memory where the string is located in the binary. Don't worry about this. You want to worry about this side right here, which this is saying the part in the code where this string is referenced. So once again, this is where the string is in memory. We care about the part where that memory is accessed by the program because it's about to load. You let the Russians win. So going over here, data xref, double click on this subroutine, and we end up in our function that prints the lose scenario. You let the Russians win, and it just kind of exits out of it. So that looks like it to me. So we can go ahead and rename this to you lose. And what's helpful about IDA is we want to know, well, what is causing us to end up in this lose function? How are we getting here? You can right click here and select list cross references to. What that's going to do is it's going to show all parts in code that call this function. And you can see it's only called once by main. So click OK. And there it is. This is where it's actually called from, and this is actually the main function that we're in right now. So what we can see here is this is a conditional branch. It's saying if some condition isn't met in this section, then jump to the you lose section. If it is met, then jump to this other function. Gee, wonder what that is. We can double click on this and make sure to see for ourselves. Yeah, look, it has the word defused in it. This definitely looks like the win path. So let's go ahead and rename this one to you win. Alright, that's that simple. We can see there's a decision made to win or lose. And the great thing about when we have control of the binaries, we don't even really have to need to know what causes us to go one way or the other because we can control it. And I'll show you what I mean. Go to the click here on the jump instruction, which what this is like think of it as an if statement really. It's comparing something before it, and if that condition is not met, then it jumps if less than or equal to here, and if not, then here. So we can see, we click on this instruction here, we see a memory where that address is, and we want to go with the offset 91A. Press Control G in OllyDbg, select offset, select our program 91A. There it is, right there. Okay, I hope this is going to work because I did edit this last time for the demonstration, but we're going to click play. Great, so it wants input here. Alright, cool, so this is good. So it broke right here. We're right at the branch where it's about to make a decision. We can see since this red line here, this is going, you can't see because I have it highlighted, but this is going to jump us into this section of code, the call, and it's already written here. This is the lose case, which is this one, and if the jump does not execute, we will end up in the win case, which is where we want to be. Since we have control over this binary, we can go ahead and do this lots of ways. We can, looking at this now, I want to do it in a way that we can patch this and actually dump this binary as a cracked version. So what I would do here is we can actually modify this instruction to something else. To modify an instruction in Ollie debug, you can just click on it, start typing, and it pulls up this. We're going to change the instruction into a no-op, which a no-op means no operation. It's nothing. There we go. That's what we did. We just changed that to nothing. And so now that we changed to nothing, what will happen is that the condition will all be calculated and determined up here. But when it actually wants to make a choice, like of what to do after that condition, it won't have a jump instruction anymore. So it's just going to go no op, go to the next one, no op, and then just land right at the win, no matter what. And so if I press continue here, that's exactly what happened. Good work. We can actually go ahead and package this binary up and what you call patching. So that's a way to debug something a little bit more difficult. If we really cared and wanted to learn what condition it's checking here, we can see that what it's doing is this comparing the value 14 hex, which is 20 in decimal, to the argc argument of main. What that means is argc, that's the argument in main. When you give command line arguments to an application, argc is what's in charge of keeping a count of how many command line arguments were given. What I see going on right here at this line, this is comparing the value 14 hex with the argc value. And if it is less than or equal to, then it's going to say that the bomb blew up. If it's greater than, then it's going to go to the win case where we defused it. And so that's a very kind of sneaky way, right? We could have guessed passwords all day long. We would have never known how to actually defuse the bomb. And that's a great that's more on the reverse engineering side of all this stuff. Was the last thing I want to get started with, just to kind of help you out with the slot machine. Let's get started there. Slot machine is on my desktop here. Click, drag it into IDA. Once again, it looks kind of similar, but this is more code was written for this one, so it's a bigger binary for sure. Click main, press space. We end up at the entry point of our slot machine code. If we run the slot machine, just to make sure you know what it looks like, this is what it's like. You press spin. We will never, I don't want to say you'll never win because I did make it possible, but it's very, very unlikely. And we get these odd values. So what I would look for here to kind of, once again, get your bearings is start looking for the text. Go into IDA here and go to open subviews, views, strings. And right here, signs and win the $15 Amazon gift code. It loads that banner right at the beginning of our program. So we want to double click this, find the reference where that string is in our code, double click that, and there it is. So we can conclude that this is the portion of code where our slot machine is being initialized or printed out, or just at least the beginning of our program pretty much. And if we go, let's go ahead and load this in Ollie debug. Alright, have an Ollie debug, and we can go ahead and click right here. And like I said, we'll do it without as if IDA wasn't on our desktop. We can click strings on here, click on the signs and win the $15 Amazon gift code, double click that, put a breakpoint here, run the application, and there we are. So let's actually start this over from the beginning. Press play. It's still remembering my breakpoint I put. Press play, and here we are. We're at the Amazon $15 gift card, that is interesting because I would have expected it not to have printed out my slot. Oh, that's because. Oh, okay, that's why. Okay, great. So that's what I expected. So we're paused. We're stuck right here, and this is kind of hopefully get you started with what to do next. And so as you can see, like if I step through, okay, it's printing out more of the text here, and then it's calling this. And this is probably a good thing that you want to step into maybe, because this is more code that I wrote, since the address is within the address space of the program. All right. Oh, wow, you see some randomness. I don't want to give too much away, but that's a good place to start. And like I said, there's many ways you can crack the slot. So have fun and good luck.